we're going to look at the congruent supplements theorem and the congruent complements theorem. So the congruent supplements theorem says if two angles are supplementary, remember that supplementary means that they add to 180 degrees. So if two angles are supplementary to the same angle or congruent angles, then they are congruent. So for example, we have 1 and 2, so this angle and this angle add up to 180 degrees. And then we also have that this angle, angle 2, and angle 3 are supplementary. So notice if you look at the picture, you've got 1 and 2 look like if you put them together would create a line. And then if I put 2 and 3 together, they would look like they would create a line. So what we're saying is that these two angles have to be congruent. So angle 1 has to be congruent to angle 3 because they're supplementary to the same angle. Now we have that same kind of idea with complements, but instead of supplementary, it's complementary. So remember that complementary means that it adds to 90 degrees. So again, if we were to squish 4 and 5 together, angle 4 and then angle 5 would create a 90 degree or right angle. And then if we look at angle 5 and then we look at angle 6, 5 and 6, if you put them together, look like they would create a right angle. So if we know that 4 and 5 are right angles and 5 and 6 would create a right angle, then we know that 4 has to equal 6. So these are our congruent complements and congruent supplements theorem. So let's take a look at how we can use this. So if we look at this one, we have that these two, notice you've got R, I'm missing a letter there. Oh, RPQ is a 90 degree. I kind of just drew over the 90 degree angle. So we have this part here, that's the 90 degree angle. So we know that RPS and SPQ add up to 90 degrees. And then we also know, notice here we've got this marking here with the two angles, or not two angles, two arcs, which means that these angles are congruent. So if this is 20 degrees, this is also 20 degrees. So then what happens is now I can know that this is 20 degrees and add the two of them together to get to, we can use our angle addition postulate to add RPS to, so RPS, we're going to add that to SPQ, and that will give us the whole amount there. Okay, so if we do 3x plus 19 plus the 20, that has to equal the 90 degrees, and we know it's 90 degrees because it makes a right angle. So if we do the 19 plus the 20, that gives us 3x plus 39 equals 90. So then I want to get the 3x so it's by itself, so we're going to subtract 39. So if we do 90 minus 39, that gives us 51. So then I want to get the x by itself, so we're going to divide by 3. So 3 goes into 5 once, we have 2 left over, 3 goes into 21 7 times, so then our x is 17. Okay. Now if we look at the next one, I'm going to erase the work that I did up here so that we can see better what's going on the picture, because I kind of went into the picture. So notice here on this one, it says HAI, so we have this piece of information over here. So HAI is congruent to KAJ. So these two angles are congruent. So we know that this one is congruent to this one. Now, see here how I used this information and then I put it on the diagram? This is something that we're going to be working on today as well, so that we can make sure that we know what information we have. So the other thing that we have, notice I drew over it, is we know that this thing right here is a right angle. So we've got this creates a right angle. It looks worse when I drew on it. It's just this part right there. That still is worse. Let's go with letters. What letter are you? K, A, I will create a 90-degree angle, right? So that means if we know that these two angles are congruent, and we know that this one is 8x minus 16, and we know that the other one is 4x plus 8, we know that those two are congruent. So we can then set up our equation so that we have 8x minus 16 has to equal the 4x plus 8. So I'm going to move my x's to the left side and my numbers to the right side. So I'm going to subtract 4x and add 16. I'm going to go up here. Okay, so then we have the 8x minus 4x, which gives us 4x. Then a negative 16 plus 16 goes to 0. 4x minus 4x goes to 0. And then 8 plus 16 gives us 24. So now I want to get the x by itself, so we're going to divide by 4. So then we get x is 6. Now, make sure you're paying attention. It said that we need to find x and IAJ. So if we look, IAJ is this angle, right? Notice we don't have a measurement for that, but we do know that these two angles are complementary, right? So that means, I'm just going to try and change my highlighter color. It's not working very well. Oh. That means we want to do KAJ, find that amount, and then since KAJ and JAI are complementary, we can subtract that from 90. So since we have, I'm still on highlighter, since we have 4x plus 8, we need to plug in the x that we have. So we have 4 times 6 plus 8. So that's 24 plus 8, which then gives us 32. Okay. So we know that this angle here is 32. Well, if we know that this part gives us 90 degrees, to find IAJ, that means that we need to do 90 minus 32 to get to IAJ. So if we do 90 minus 32, I'll get rid of this arrow, most of it anyways, that gives us 58. So that's the measurement of angle IAJ. No. I have to use my finger on the iPad and it's not working out very successfully. IAJ. But I don't have a pen that will make it so that it writes nicely today anyways. So that is how we can use that. Now, if you look at the next part, this one we need to draw a picture to represent what's going on. So on this one it says, given that angle 1 is supplementary to angle 2, and that angle 2 is supplementary to angle 3. Oh, sorry. Angle 1 and 2 are complements, angle 3 and 4 are complements, so then we know that 2 is congruent to 4, or we also know 2 is congruent to 4, so 1 is congruent to 3. So I'm going to make two angles that look like they're complementary. Remember, complementary means that they add to 90. So I'm going to create this picture and this picture. So this will be 1, this will be 2. Then I know that 3 and 4 are complements. So I'm going to draw a 3 and a 4 as well. I'm going to draw a similar picture. Now, before I start drawing the picture, notice here that 2 and 4 are congruent. So I want to draw my angle 4 to look exactly like the same measure as angle 2. So this is going to be my angle 4, and then it's supplementary to, or complementary rather, to 3. Okay, so 3 and 4 are supplementary, and 1 and 2 are supplementary. and we know that 2 is congruent to 4. So to show that 2 is congruent to 4, we need to do little arc marks on there. So 2 is congruent to 4, right? So we're not showing how we know that 1 and 3 are congruent, but it should make sense. If 1 plus 2 has to equal 90, so say 2 was 45, that means 1 has to be 45. Well, if 2 is 45, 4 is also 45, which means that to get to 3, I do 90 minus 4, so 3 is also 45. Okay, if we try it with 60, so if we do number 2, angle 2 is 60, that means angle 1 is 30. But angle 2 and 4 match, so 4 is also 60, which means that 3 also has to be 30. Okay, so that's the kind of picture, that's how we get there. That's all that we're doing is creating the picture. Now the next thing that we're going to look at is 2 theorems. We have the perpendicular bisector theorem, and then we have the converse of the perpendicular bisector theorem. So the perpendicular bisector theorem says if P is a point on the perpendicular bisector, remember perpendicular means that it hits at a 90-degree angle and it cuts it in half is the bisector part. Okay? So if a point's on the perpendicular bisector, so this is perpendicular, it cuts this part in half, so these two measurements are the same. So P would be on the perpendicular bisector. Oh, and we didn't necessarily call the point P. I'll call the point P. Oh, yes we did. P lies on the perpendicular bisector. Then we know that LP is congruent to LM. So notice we have the picture down here as well. So if you know that this is a perpendicular bisector, then you also know that these two parts are congruent. Okay? Then the converse means that you go the opposite direction and you switch the hypothesis and the conclusion. So our conclusion was that we knew that LP was congruent to PM. So now we're going to say that's our if part. So if these two parts are congruent, then we know that point P lies on the perpendicular bisector. Okay, so that's the two ways that our theorem goes. Now let's see how we use this. Okay, so it says for find x and y on the picture to the right if PO is the perpendicular bisector. So notice it's already got the perpendicular on there. Now just so you are aware, the way that we represent perpendicular is like this. So I could say PO is perpendicular to LM. So I also could write it like that. So this notation, notice it looks like two perpendicular lines. That notation would also be perpendicular. So we know it's the perpendicular bisector, which means we now know that these two things are equal. So then we can say, this is for the next one that we're going to do. So then we can say x equals 40, because we know LO and OM are congruent because it's the bisector. Now, the other thing that we know about a perpendicular bisector is that when you have a point P on the perpendicular bisector, it's congruent from the point to the end point. So the two yellow parts are congruent. So if we know that Y is, or that 62 is the LP, then we also know that PM has to be 62 as well. But notice that's our length of Y, so 62 has to equal our Y value. So let's try another example. So here we have, the instructions are on the page before, but we want to know what can we tell about Q. So notice here we have the converse part is true. We know these two parts are congruent because both of them are 3. So that means that this point right here has to lie on the perpendicular bisector. Okay, so all we know is that Q is on the perpendicular bisector. Okay. Now, if we look to the right, we have this picture over here. Notice we know that it's perpendicular because we've got this part right here that says it's a right angle. And we know that these two parts are congruent. So we know that AC is congruent to CB. So we know that the DC is a perpendicular bisector. Well, if we know it's a perpendicular bisector, we know this amount is equal to this amount. So that means that I can set those two expressions equal to each other. So I can set 4x minus 1 equal to x plus 11. So then we subtract x, and add 1, so we get 3x equals 12. So then we divide by 3, so x is 4. Now, look at our instructions. It was find the value of AD and to find x. So we've got the x part, but we need to find AD. So if we go back and look at our picture, AD is this part right here. So I'm going to do 4 times 4 minus 1. So that gives us 16 minus 1, which gives us 15. So then we know that AD is 15. So that's our perpendicular bisector and the converse of the perpendicular bisector. This last part you should already really be familiar with these. We'll just go through these to make sure that you're aware of all of them. Again, this is a definition, vocabulary kind of day. So we've got triangles. There are 2 ways that we classify triangles, by their sides and then by their angles. Okay? If we're doing angles, we have 4 different kinds. We've got a right triangle. Notice that it has exactly 1 right angle. And then we have an acute triangle where all 3 angles are less than 90. We have an obtuse with exactly 1 angle that's obtuse. And then we have equiangular where all angles are congruent. When we look at the sides, we only have 3 that we classify them with. So we have isosceles. Isosceles are 2 congruent sides. I like to think of the SOS in isosceles stands for same, odd, same. So you have 2 of the same side and then 1 odd man out. You also have an equilateral triangle where all 3 sides are congruent. And then you have scalene where all of them are different. Okay. So if we look at these examples down below, we're classifying these by its sides. So for sides, we have these options. So notice we have here AB is congruent to AC. Again, we're looking at our picture, and I know that those 2 are congruent. Now, if I were to write the congruency off to the side, you would have AB is congruent to AC. That's how I would write that from our diagram. So if there's 2 sides that are equal, we call it isosceles. So this one is an isosceles triangle. If we look at this one, we know all 3 sides are congruent. So when all 3 sides are congruent, we call it equilateral. Here we have this is 1 tick mark. We've got this one is 2 tick marks, and this one is 3 tick marks. So none of them are the same. So this one we call scalene. So now let's look at classifying the triangles by their angles. Okay, so if we're looking at classifying these triangles by their angles, we want to look at the first one. Notice the first one we have the box, which means that it's going to be a right angle, which means that this one has to be a right triangle. Okay. If we look at this, notice all 3 are the same value. When all 3 angles are the same, we call it equiangular. Here, this is 80, that's acute. 45, that's acute. 55, that's acute. So this one has to be an acute triangle. If we look at this one, we have 130 that's obtuse. As long as there's 1 obtuse, it makes the whole triangle obtuse. And then if we look here, notice that this one we've got 90 degrees. So as long as you have 1 90-degree angle, that's going to make it a right triangle. So notice on this right triangle that we like physically on the right side of the paper, that we put 90 degrees, and on the one on the left side of the paper, we had the box. So you can have it both ways. So that is the information about our triangles. Now, there's a couple other things that I want to make sure that you know. When you're marking up your diagram, it can either give you the information, or you can have the diagram and you're pulling the information off of it, or you can be creating a picture based on some information. So if we were to look at the one thing you do need to know that you haven't been told yet is that this means that they're parallel. So if I say AB is parallel to CD, okay, sometimes the lines are more straight up and down when it's written with a computer. Mine by hand I go slightly sideways, maybe not quite that sideways. So I'm going to create a line segment. Notice I know it's a line segment because we don't have any arrows. So I'm going to call this AB. Okay. Then I know it's parallel to CD. So So this is C, this is D. Granted, I didn't draw my parallel lines spectacularly. Now, the way that we show parallel lines on a diagram is we use these little arrows. So if I wanted to say these segments were congruent, then I would use the tick mark, right? Remember, we do the tick mark to show that they're congruent, or we could do 2 tick marks. So that would say that AB is congruent to CD, okay? But with the arrow, that's telling us that they're parallel. So I may be giving you information where you put the picture, you put the information on the picture, or you create a picture, or you're pulling information off the picture and you're telling me what information you know based on that. So let's take another example. So if we take a look at this picture here, notice we have several pieces of information that we can look at. If we look here, this information lets us know that the lines are parallel. So we can write off to the side. Notice here that we have this line is called L and this line is called N. Remember, that's a cursive N. So I can say that L is parallel to N. Okay. Notice we also have where we can take a look at this and see that these 2 things are congruent. So if those 2 things are congruent, the way that I write that is HO is congruent to OT. Okay. Notice we also have this part down here where we have that we've got perpendicular lines. So notice these are perpendicular lines. So I can also say here that we could call it XH or XO or OH. So we could say line OX is going to be perpendicular to XA, to show that those 2 things are perpendicular. So that's how you take the information off of the diagram and put it in mathematical notation.